In this video, we're going to learn how to solve systems of equations by elimination method. And we have 4 examples plus an application problem. So when you are solving by elimination, the whole goal is to eliminate one of your variables. And you do that by having the same coefficient, but one coefficient is a negative and one is a positive. For example, this one is already set up for us to use elimination. You have negative y and then a positive y. And so those are going to eliminate. And so now we're going to add what's left together. So 2x plus 3x gives me 5x. Negative 8 plus 3 is negative 5. Divide by 5 and we get x is negative 1. So then plug it into either of them to get your y. I'm going to pick the bottom one just because it has no negatives, and that seems easier to me. So this is 3 times negative 1 plus y equals 3. We get negative 3 plus y equals 3. Add 3 over. And y equals 6. We always write these as ordered pairs. So my ordered pair is negative 1, 6. That answer should look familiar because we have now solved this problem 3 different ways in getting the same answer. We solved it by graphing to get negative 1, 6. We solved it by substitution to get negative 1, 6. And now we have solved the same problem by elimination to get negative 1, 6. Now, while this one was set up for elimination, this one does not automatically have something that you can eliminate. So we have to do a little bit of work. In this one, I can see that my x's do have a positive and a negative. And so I'm going to go ahead and try to get rid of my x's. So I'm going to multiply this whole equation on the top by something to try to get it to eliminate. If I'm getting rid of that x again, 2 times what gives me 6 to eliminate this, and that's 3. The biggest mistake with this is that we will remember to multiply our x and our y, but we forget to multiply this coefficient. You are multiplying the entire equation, not the variables, but all 3 terms. So now this top equation here becomes 6x plus 3y equals 12, because I'm doing 3 times 2x, 3 times y, and 3 times 4. Once you do that, you're almost not even paying attention to this top equation here anymore. So these are my 2 equations. So now my x's are going to cancel with each other. Negative 6 and a positive 6 cancel. But kind of notice what happens. You've got a negative 3y and a positive 3y. Well, those also cancel. And we have negative 12 and a positive 12. Those also cancel. When everything cancels, it means I have 0 left on this side and 0 left on this side. Because this is a true statement, my answer here is infinitely many solutions. Okay, when your variables both cancel, so in this case, both my x and my y canceled, when that happens, it's always going to be one of your special cases. And so in this one, we have the exact same line on top of each other. I am personally fine with this being your final answer and you being done with it. However, your homework's going to ask you to take this a step further and kind of come up with a formula or an equation that will give you any of these infinitely many solutions. So when they ask you to do this, they're either going to tell you that X or Y can be any number. If they say that X can be any number, then that means you have to come up with what Y is going to equal. So if I take this first equation here, I'm going to kind of come over here. You need to solve this for Y. So we would solve by Y or for Y by subtracting 2x over, and we would get Y equals 4 minus 2x, or you could write that as negative 2x plus 4. It doesn't matter. Okay, as long as the signs are the same. Your 2x needs to be negative and your 4 needs to be positive in whichever order you write it. So when X is any number, then you have to take one of the equations and solve for Y. And if you were to take the second one, you would get the exact same answer. So it doesn't matter what you do. If we took the second one, we would add 6x over. I'd get negative 3y equals negative 12 plus 6x. We would divide everything by negative 3. Negative 12 divided by negative 3 is a positive 4, and 6 divided by negative 3 is a negative 2x. So it doesn't matter which equation you pick. So pick the simplest one. So when they say X is any number, you're solving for Y. Pick an equation, solve for Y, and then that ordered pair now becomes X, comma, 4 minus 2x. So this means you can now make an ordered pair of any of these infinitely many solutions. So if X is 4, you can plug in 4 here and figure out what's your Y. If X is 100, you can plug in 100 and figure out what your Y coordinate is. This is a formula to let you find any number of these infinitely many solutions. So then likewise, if they say that Y is any number, then that means we need to solve for X. Just like here, when I solve for Y, it doesn't matter what equation I pick, I'm going to get the same thing. Just pick one of these equations and solve for X. So if I pick the top one again, and now I'm solving for X, I'm going to subtract my Y over. And now divide by 2. And so X equals 2 minus 1/2 Y. And so that ordered pair is now, it's always X comma Y. So it's 2 minus 1/2 Y, comma, Y. And this is the exact same thing as this one here. You're going to get the same answer no matter what, but now you're picking what Y is and you're plugging this in to get your X coordinate. But if you get infinitely many solutions, you're going to be asked to come up with this formula or this ordered pair to generate any number of these infinitely many solutions. Sorry about you. Okay, moving on. Here, nothing automatically eliminates, right? Like it did here. And here, you have nothing that's opposite sign. So I at least had a positive and a negative. Here you don't. So just pick anything you want to eliminate. If I want to eliminate my X's, what do I have to multiply 2 by to eliminate it with this 4? Be careful. If you said 2, when you multiply this out, you get 4x. Those don't eliminate. That becomes 8x. You need them to have opposite signs. So if I multiply it by a -2, now this becomes -4x, and now those will eliminate. And we're going to remember that when I multiply something, we're multiplying the entire equation, not x and y, but x, y, and that constant. So -2 times 2x becomes -4x, -2 times y becomes -2y, and -2 times 5 is -10. So I am again not looking at this first equation anymore. These are my now two equations. So my x's do eliminate because we have a +4 and a -4. So those are gone. My y's also eliminate. So 2y and a -2y, those are gone. But my constants do not eliminate this time. So on the left side of my equation, because everything cancels, I now have nothing over there, so that's 0. And 8 plus a -10 is -2. This is a false statement. Before it was true. When it's true, it's infinitely many. When it is false, this is no solution. Your no solution graphs are your parallel lines. So they'll never ever intersect. You know you have one of these special cases when both your x's and your y's eliminate. The difference between the two is if the constants eliminate as well. When they do eliminate, it's going to leave a true statement. When they don't eliminate, it's going to leave a false statement. So in example A, we already had something eliminate. And B and C, we only had to multiply one equation to get something to eliminate. On D, I can't multiply just one. I can't multiply 2 by something to eliminate it with 5. I can't multiply 3 by something to get it to eliminate with 10. I don't care if my constants can eliminate. I need to eliminate my x or my y. So when that happens, we have to multiply both equations. So if I want to eliminate my x's again, and I'm going to pick x just because one's already negative and one's positive, so I don't have to worry about multiplying anything by a negative. Okay, so if I'm going to eliminate my x's, I can get these two to become 10s. And so to get -2 to become a 10, I need to multiply it by 5. And to get 5 to become a 10, I need to multiply it by 2. Okay, so I'm just kind of picking something that I know I can multiply these two numbers and get them to the same number. We could have also done 20. You could have multiplied 2 by 10 and 5 by 4 to get them to be 20x. It doesn't matter, just get them to multiply to the same number so they can't eliminate. So when I multiply this top one by 5, I'm multiplying all three terms. And we get -10x plus 15y equals 5. And then multiply the bottom one by 2. We're multiplying all three terms again. So 10x plus 20y equals 30. So now I'm not paying attention to my first two. These are my two equations. My x's eliminate because I have a negative and a positive. 15 plus 20 gives me 35y. 5 and 30 give me 35 as well. So when I divide by 35, I get y equals 1. So plug that back in and get your x. You have 4 equations you can plug that into. Your original 2 and the 2 new ones we made. It's always going to be easier to go back to these originals because they're going to be easier and smaller numbers. So if I plug this into the top one, I'm going to get -2x plus 3 times 1 equals 1. So this is -2 plus 3 equals 1. Subtract your 3. -2x equals -2. Divide by -2. And x also equals 1. So my answer is 1, 1, because when I have one solution, we're going to write it as an ordered pair. So let's now use that method of elimination to use it to an application problem. A movie theater sells tickets for $10, each senior receiving a discount of $2. One evening, the theater sold 525 tickets and has revenue of 4,630. How many of each type of ticket were sold? Okay, so you can pick variables of X and Y. I like to pick variables that kind of make sense to the problem. That way I don't have to figure out what did I assign X to be, what did I assign Y to be. So I'm going to call regular price tickets T and my senior tickets S. The first equation always has to do with the number we're selling. So I know the number of regular admissions tickets we sell plus my senior discount tickets. Those need to add up to the total amount of 525. So whether this is 500 plus 25, whether this is 300 plus 225, whether this is 5 plus 520, whatever these total are, they need to add up to 525 tickets. So the first has to do with the amount. The second equation needs to have to do with the money. So how much do my regular tickets cost? Well, those are $10 each. So this is 10T. Plus, how much do my senior discounted tickets cost? Okay, hopefully you said 8. Right, they're receiving a discount of $2, which means they're $8 total. So be careful in the wording. Equals my revenue was $46.30. The amount, the money. So let's try to eliminate something, and it doesn't matter what. Both of these are both positive, so let's just pick T. What would I have to multiply this T by to get it to eliminate with a 10T? Hopefully you said -10. You got to change that sign since they're both positive here. So my new equation is -10T minus 10S equals -5,250. We're multiplying all three terms. So now I don't care about this top one. And let's eliminate. 10 minus 10 is 0, so that's gone. 8 minus 10 is -2, so -2S. 4630 minus 5250 is going to give me -620. Divide by -2. And S equals 310. So now to get T, plug it in. This is the most basic equation you're ever going to get. So let's plug it in here. T plus 310 equals 525. Subtract it over. And T equals 215. Now with this, I don't care about an ordered pair, right? Because we're working with a word problem here. It wants us to answer how many of each type of ticket were sold. Well, the movie sold 215 general tickets. And 310 discounted senior tickets. And that's again why I like assigning variables here that make sense to the problem. That way I don't have to say, oh, what did I make T equal? What did I make S equal? It makes sense to the problem that was used. But if you like X and Y, that's fine. Just make sure you know what X equals and you know what Y equals so that you can tell me and answer the question.